Hello everyone, welcome to Unify Chem Study channel. So as I am discussing about the chemistry of DIBAL compound, so in this particular lecture we will discuss about some important application of DIBAL reducing agent. So here you can see, so if you take this substrate, where you can see this particular substrate is called alpha beta unsaturated ester. Now if you try to do the reaction in presence of DIBAL compound, the amount is 2 equivalent in diethyl ether solvent medium at low temperature. So you can see that this particular compound selectively reduces this ester group, and as a result it gives this kind of alcohol product. Okay, why it does not give the aldehyde? Because you can see the amount of DIBAL here is used as a 2 equivalent, as well as here that polar solvent is used. Okay, diethyl ether, it is a polar solvent, so that is why this particular ester group gives alcohol product. Now coming to the next example, here you can see how to convert acid to aldehyde. So this is the overall reaction scheme, as you can see. So let's say if you try to reduce the acid group in presence of lithium aluminum hydride, as you know that lithium aluminum hydride, it is acts as a strong reducing agent. So as a result, so this acid group directly gives the alcohol product. But here how to convert acid to aldehyde? So initial step is, so if you take acid and do the reaction in presence of trimethyl silyl chloride, in presence of triethyl base and dichloromethane solvent medium, so initially it gives trimethyl silyl ester. Now that ester, trimethyl silyl ester, if you do the reduction in presence of DIBAL and lower temperature, then it selectively gives the aldehyde product. So that reaction is very important. Now further, coming to the next example, here you can see this particular substrate, it contains how many ester group? This is one ester group, another ester group is also present over here. Now if you do the reaction by using DIBAL, here you can see 1.4 equivalent. Okay, 1:1.4 equivalent, then selectively it reduces this particular ester group over this ester group. Okay, so as a result it gives this aldehyde product. Now further, if you take this kind of coumarin based compound, here you can see this particular group is also cyclic ester. Now do the reduction in presence of DIBAL toluene medium, so it gives this product, and finally it gives this aldehyde product. Now if you take if you take this cyclic alkene O methoxy group containing compound, and if you do the reaction in presence of DIBAL and isooctane reflux solvent medium, so as a result, as you can see, this is the mechanism. So that DIBAL hydride, it will attack here, and as a result it forms this kind of alkene cyclohexene compound. But here you can see the percentage of yield of this product is very less, near about 30 to 35%. Okay, coming to the next example. So if you take this alkyne compound, alkyne, you can see there is a presence of carbon-carbon triple bond. Okay, so you can say the name of this compound is diethyl acetylene. Now if you do the reaction in presence of DIBAL, 50 degree centigrade temperature, initial step, so that hydride DIBAL, it will attack here. Now as a result it gives this kind of intermediate. Now further, if you do the reaction by methyl lithium, so this is one of the most important organometallic compound. Now that methyl lithium, that methyl group, it will attack here, then as a result it forms this compound. Now if you do the acidic workup with carbon dioxide, so it gives this kind of product. So this is one of the main important application of DIBAL compound. Now once, how to convert that cis, you can see this is cis product, cis product. Now how to convert this compound as a trans product? So here you can see, initially if you do the reaction in presence of DIBAL and methyl lithium, now it forms this kind of tetrahedral intermediate. Now further, if you add this substrate diethyl acetylene, so as a result, as the size of this particular intermediate is bulky, so it will attack here, and as a result it gives this product. Now at ordinary temperature, ester and ketones are reduced to alcohols, nitrites gives amine, and epoxides are cleaved to alcohol. That is one of the main important application of DIBAL. So next example, as you can see here, so if you take this substrate, where you can see it contains, this is one of the ester group, O methoxy group is there, and ether group is also there. So therefore if you do the reaction in presence of DIBAL and dichloromethane, so it gives this aldehyde product. Now further, if you take cyanide compound, so that cyanide converted into aldehyde in presence of DIBAL. So the last example, as you can see here, DIBAL is used for the selective 1:2 reduction of alpha beta unsaturated carbonyl compound to allylic alcohol. So this is the alpha beta unsaturated ester. So as a result it gives, selectively reduces this ester compound, and as a result it gives alcohol product. Thank you very much for watching.